There's a strange place in the sky where everything is pulled. Unfortunately, it lies beyond the Milky Way and we can't see it directly. So what is this great attractor? Our home, the Milky Way galaxy, where our solar system resides, has a diameter of 100,000 light-years. Its mass, according to the latest calculations from 2016, is 700 billion times heavier than the Sun, including the mass of black holes, cosmic dust, and dark matter. Hypothetical dark matter accounts for 88% of the total mass. The Milky Way, along with the Virgo galaxy cluster, the Coma Berenice's galaxy supercluster, and other cosmic matter clusters, is hurtling at an unimaginable speed of 600 kilometers per second towards some as yet unknown but incredibly powerful source of gravity. What is the Great Attractor? The Great Attractor is an immense gravitational anomaly located 250 million light-years from Earth in the constellation Norma. Judging by the effect it has on the galaxies we observe, the attractor possesses a mass tens of thousands of times that of the Milky Way, making it not just colossal, but practically unimaginable from a human perspective. A significant portion of our visible universe is being drawn into this strange funnel, where probably so much matter has accumulated that it's impossible even to conceive. However, astronomers have not yet been able to discern anything in that distant region towards which we are all rushing. This is because the Great Attractor lies in the direction of the constellation Centaurus, and the disk of the Milky Way blocks the light from the universe hidden behind it. Thus, astronomers have fantastically well-mapped most of the large-scale structure of the universe, except for the area where they had to look through our own galaxy. And it is precisely there that the Great Attractor is hidden. However, by the effect this anomaly has on galaxy clusters, its location can be easily determined. Over time, astronomers have been able to get closer to studying this region using X-ray and radio telescopes, initiating a murky, unclear sketch of a still unknown part of the universe. Scientific explanations and unanswered questions. How do scientists explain such a mysterious anomaly? The Great Attractor itself is located in the southern hemisphere sky. It stretches from the constellations Pavo and Indus to the constellation Vela. In its midst lies the galactic cluster in Norma, almost completely obscured by the Milky Way. Its vicinity contains many large and ancient galaxies, which frequently collide with each other, emitting powerful streams of radiation. This giant gravitational anomaly affects other superclusters. Very recent studies by the Planck satellite have shown that the overall movement of galaxy superclusters towards the Great Attractor might be caused by something far behind it, something beyond the boundary of our observable universe. Perhaps an incredible amount of still unknown dark matter is hidden there, and the mass of the Great Attractor itself may have been exaggerated tenfold. Here, established facts move into the category of shaky assumptions that can be refuted or confirmed by any subsequent observation. Today, the standard model of particle physics cannot explain the phenomena of gravity and the accelerating expansion of the universe. A breakthrough in science, comparable to the development of quantum theory, would be the creation of a unified model that would encompass all known physical phenomena in nature. Even more questions were left by scientists who were able to model the process of the universe's formation on supercomputers. The equations included all known forces in science, but in the end, the model showed no attractor. In other words, such a structure simply cannot exist in nature. And in general, what makes galaxies flock together? Perhaps galaxies are not just a collection of matter. Perhaps they are even intelligent. The most daring hypotheses arise, attempting to explain the attraction of galaxies to each other. Nobel laureate in physics, Hannes Alfvén, suggested that another force, as yet unknown to us, exists in space. Perhaps giant cosmic structures arise due to plasma currents, electrically charged and high-energy gas flows, and the magnetic fields they create. However, scientists are increasingly leaning towards the theory of multiverses. Our cosmos is just one of such non-overlapping universes. This theory could indirectly explain the existence of the Great Attractor. What if our universe leaked, and now we are all simply being sucked into a neighboring universe by a kind of pressure difference? Is the Great Attractor a threat? American astrophysicist Paul Sutter pondered a question that probably occurred to each of us at the very beginning of this video. Is the Great Attractor a threat to us or not? And he came to what seems to be the most logical conclusion. Over the past 13 billion years, matter accumulated into small clumps, which merged into larger clumps, which merged into even larger clumps. Understanding what a supercluster truly is marked the beginning of unraveling the mystery of the Great Attractor. After all the closest objects to us, including the Milky Way, Andromeda, the Virgo cluster, and its surroundings, are heading towards it. Instead of simply being a big blob of galaxies, a supercluster came to be defined as a volume of space in which all galaxies flow towards a common center. The Virgo supercluster is not an isolated object. It is part of an even larger structure, Laniakea. By looking at supergalactic structures through the prism of matter flows, it's easy to understand what is happening with the Great Attractor. We live in a hierarchical universe, assembled from small structures, galactic blocks. The Milky Way and Andromeda are heading towards the center of the local group. All the material in the Virgo supercluster falls towards its center, the Virgo cluster, and everything in Laniakea falls towards its center, the Norma cluster. Thus, the Great Attractor is actually the coordination center of our region of the universe, the end result of a process set in motion more than 13 billion years ago, and a natural consequence of the flow and accumulation of matter in the universe. We will never reach the Great Attractor. Dark energy will tear the Norma cluster apart. Clusters will remain as they are, but the fate of superclusters is predetermined. Therefore, we have no reason to fear the Great Attractor, reassures Paul Sutter. However, not all galaxies are so lucky. The Hubble telescope has captured how the Great Attractor affects galaxies and galaxy clusters that fall into its gravitational field. Photographs from the telescope show how the spiral galaxy ESO 137-001 in the constellation Norma has been caught in the attractor's nets. The Great Attractor essentially rips streams of cold gas and stars from galaxy ESO 137-001, thereby depriving the galaxy of hydrogen, which in turn, after some time, will lead to the cessation of star formation processes in that galaxy and its demise. In this place, there will only be total, impenetrable cold darkness, in which the light of even the closest galaxy clusters will be so dim that it will be impossible to discern them,